Alfredo Vellido from the Polytechnic University of Catalonia is going to talk about explain yourself, XAI as social responsibility.
What I was explaining before was that I belong to the Intelligent Data Science Artificial Intelligence Research Center, in which I am the co-coordinator of the Health, Wellness and Inclusion area. And that's because I've been working in medical applications of artificial intelligence and machine learning for 25 years now, roughly. I'm not just making kind of blatant publicity of the center itself. I'm saying this because it somehow exemplifies what's going on with machine learning and artificial intelligence, and in particular in the area I work, which is that suddenly over the last few years, everybody seems to be willing to talk to us, to the people who do data science, artificial intelligence, and machine learning. They are knocking our door. But the problem is that only a few years ago, we didn't have this door. And we have created this center 3-4 years ago just to have that door. I mean, some place where people can find us. People can find us means people from industry, people from hospitals, even students interested in research. And we have now a single door for that. Only 10 or 15 years ago, this would have been completely unnecessary. And this is somehow a hint of to what extent our area has become, once again, because this is not the first time, extremely fashionable. That's okay, but it also comes with a burden and with a price tag. Probably you have heard this in news, you know, this thing that Black Lemoine, an engineer at Google, got fired, was sent home to have a nice cuppa, because he claimed that the language model he was working with became sentient, you know, cognitively active, which is a weird claim. Yeah, but the point is that this thing wouldn't even have made the news a few years ago. I mean, this would be just you know, another wacko claiming something. But right now, these sort of things go to the social sphere, to the media sphere. Everybody hears about this and creates really wild expectations about what artificial intelligence and machine learning can do for society, you know. And I work in that context, so that truly worries me, because I mean, some people say that, you know, claiming, and in my opinion, rightly so, that claiming that a system like this, advanced as it could be, can be sentient is absolute bollocks. Excuse my French. It's mystical thinking. When I heard this news, I didn't really elaborate on it, but then I thought, well, I mean, this comes to the problem of interpretability and explainability and the transparency in the models that I'm really worried about. Why? Because I mean, this guy is making a kind of very subjective interpretation of the own system he has generated. Probably he knows very little about biological intelligence, but still he's doing this interpretation. And that's because interpretability and explainability is a really key problem. You know, another example about how I realized about this was, I mean, we were organizing in NIPS, now NIRIPS, at the NIPS conference, we were organizing a workshop on explainability and interpretability in some areas. And then there was this other workshop, ML for health, machine learning for health. But the point was, I mean, what really shocked me was even the title. What parts of healthcare are ripe for disruption by machine learning right now? You know, why would you want to disrupt healthcare? Healthcare is a public service, you know, it's a delicate machine. You know, you really wouldn't want to disrupt it with machine learning or artificial intelligence. The point is that behind this, there were actually, you know, the usual suspects, you know, Google DeepMind, Microsoft Research New England, few hospitals as invited clinical panel. I mean, nothing wrong about this. Private companies can do nice things in this area, but if these companies are trying to disrupt the system, I mean, we should be concerned from a social point of view. So, I mean, I always say, even to my postgraduate students, please get social. I mean, let's not ignore the many important topics around the social impact of machine learning and artificial intelligence. An example of this was in The Guardian, there in the UK. This was well, roughly 4 years ago, counts its efforts to tackle child abuse by analyzing data with artificial intelligence, almost 400,000 people's data analyzed. When I first read this, well, it was like, again, okay, it's fine. I mean, it seems like a worthy cause. But then I thought, these people have private data, public data, patients' data, and they can, what if something goes wrong? What happens with false positives or false negatives? I mean, who pays for it? And I was even more concerned about the fact that, some of these councils have hired private companies. Hackney and Turok have hired Shantura private company to do this type of analysis. So they have outsourced public data, patients' data to this company. I mean, nothing wrong with this company. Public finance, innovation award, whatever, funded in 2008, helping clients to improve their ability to support vulnerable groups. I mean, seems all right. But I mean, there are so many things that could go wrong from the point of social impact of a venture like this, So let me list just a few of the issues that have social impact when related to artificial intelligence and machine learning. Legislation, regulation, there are plenty of regulations around that are going to affect us. Explainability, interpretability, and transparency, which are the topics I will focus my talk today. Privacy and anonymity, ethics and fairness, and the overlap of it all. Because, I mean, all these topics usually come together, Well, this is some publicity about the paper I published on this issue. All in all, what I'm trying to push today as a headline is that we need to design models from a human-centered perspective. I mean, we need to incorporate human relevant requirements and constraints. I mean, we can not just devise machines that do some very nice calculations and output some very nice competitive results in a challenge. It's much more than that. I mean, we need to get to the human part of it. From the point of view of interpretability and explainability, it's not just a technical issue. I mean, we can obviously address this as a technical issue. I mean, how can we make our machine learning models for whichever application interpretable, explainable, transparent? How can we avoid the black box syndrome? But the point is not just technical. I mean, not anymore. I mean, it's into law and into regulation. And when it comes, at least for the European Union, I mean, we have the GDPR, which was enforced in 2018, and all EU countries have to go for it, I mean, without any changes. There is Article 13 that very specifically provides citizens in the European Union with a right to explanation, what they call a right to explanation, on any decisions made by automated or artificial intelligence algorithmic systems. There must be a data controller here who is ultimately responsible to provide meaningful information about the logic involved, the significance, the envisaged consequences of whatever decision based on algorithms. That obviously is going to have an impact on any machine learning, artificial intelligence as applied to, in this case, for instance, in my area, medicine. Not just GDPR, probably you're aware that the European Commission is about to release the Artificial Intelligence Act, in which certain areas of application of artificial intelligence and machine learning are going to be considered according to, stratified according to different levels of risk. If you get into high risk or if you get into very high risk, you're going to be forbidden to apply to that area. But even if you get high or moderate risk, then you need to comply with a number of transparency requirements. So that means that interpretability and explainability is going to be almost enforced by law. Problem is, even the concept of interpretability and explainability in machine learning and artificial intelligence is still not settled. I mean, its understanding is on the making. I mean, a paper I truly recommend to read about this is this one by Doshi, Vellido, and Kim, towards a rigorous science of interpretable machine learning. This is an archive preprint, but it's a massive paper. It's very, very good. And you know, it claims that many of the problems with explanation and interpretability have to do with limited understanding of the problem itself, or a mismatch between the modeling objectives, so data science objectives, if you want, and the goals from an application point of view. Even if you want to get technical about it. Okay, transparency is something that is going to be requested directly by regulations. Transparency means that you have to consider concepts like correctness of your models, completeness, and comprehensibility of whatever you make an interpretation with. And even that is going to be further, you know, detailed in sub-objectives. Correctness is basically about how much explanations or interpretations with given feature important indicators are true to the model predictions and the extent to which their values are uniquely defined for a given prediction task. Mind you, this is mostly about the impact of a specific data features, variables, or attributes on the final interpretation or explanation. And even that has like different levels: sensitivity, stability and consistency of the explanation, fidelity and faithfulness, diversity, continuity. I mean, I won't get into detail because it can be long, you know, but this is purely technical. I mean, there are technical measures for all this. Completeness, which is the coverage of the explanation in terms of the number of instances, data instances it explains. Can be local, global, something in between. Also comprehensibility, you know, which it actually evaluates or tries to evaluate the usability of the explanations, how quick and easy they are to grasp by the end user. Again, this can be subdivided, grounded, and understandability, compactness and sparsity, efficiency of the explanations. But I mean, for me, this part, comprehensibility, is the most important when it comes to real applications, and needless to say, especially when those real applications are medically oriented or clinically oriented. Because the point, and that's one of the main points I'm going to try to make today, is that when it comes to you know, comprehensibility of the explanations, I mean, we are getting into the human factor. You know, is the human expert, is the data scientist, the one who has to make valid that interpretation or explanation. It is the one that has to interact with the data analytic system, the data analytic pipeline, with the data themselves, with data models, or even tweaking the interpretation tools in order to make something that is comprehensible and useful. Without that interpretability, that type of human-related interpretability, in most practical applications, we are completely lost. I mean, probably whatever sophisticated method we implement is going to be useful. And one of the main reasons for that, and I'm talking now very specifically in the biomedical area, there is a massive gap between the data, the information, the patterns we can extract from the data, the knowledge we can extract from those patterns, and the ultimate human-based decision-making. Yeah, and I insist on this. Machines may learn, but are the doctors who ultimately decide. Yeah, decision-making is still, and is going to be in the foreseeable future, in the healthcare, medical, clinical sector, a completely human-based endeavor. I mean, you can use your machine learning algorithms to support decision-making, and that's that. And even that, it's going to be complicated because you are going to have to comply with, as I said before, regulations, etc. That means that in one way or another, we need some sort of formalization for this type of interpretability framework. I work a lot on visualization as a tool for interpretability and explainability. And there have been advances in this area. Usually we can divide, as I said, we have the human analyst here on the right, and this human analyst is going to control the whole cycle of data preprocessing, machine learning-based modeling, visualization, if there is visualization, etc. But the key point here is that this human analyst has lots of analysis scenarios. I mean, confirmatory analysis, confronting ML results, adapting ML pipelines, what-if analysis, also, and importantly, expert verification. You know, and in the medical area, that means talking to the medical expert. Yeah, what I'm claiming here is that there is no way we are going to get real interpretability, real transparency in our systems unless we pact, agree, negotiate what that means with the medical experts. Yeah, the medical expert should ask for a few things to the data scientist, and the data scientist should ask for a few things to the medical expert. For instance, the medical expert should ask the data scientist for guarantees of medical interpretability. I mean, not any interpretability is medical interpretability. Yeah. Also, it should ask for compliance with protocols and guidelines. You know, doctors work with protocols and guidelines, and they should not get away from them. So, I mean, we need to comply with that. And also, there has to be compliance with the point of care workflow. You know, people, I mean, clinicians work in a very specific way with a very specific workflow at the point of care, in a hospital or whatever. I mean, you cannot ask someone who is in critical care, in the critical care world, to go away from the workflow or the guidelines. So in turn, the data analyst should ask the medical expert for a clear statement of interpretability requirements. I mean, with what sort of interpretability and explanation would a doctor be happy or a nurse be happy? Yeah. Also, doctors must, in advance, understand the limits of machine learning-based model interpretation. I mean, we cannot just, I mean, these are not oracles, you know, these are machine learning pipelines. So limitations should be clearly stated. Also, data scientists should ask for a clear description to the doctors of the medical decision-making process, because doctors make decisions in very, maybe, unusual ways, you know, at least from the point of view of a data scientist. I mean, some diagnoses, for instance, are based on a voting system between different experts in the same area. I mean, this is something, you know, if you are not aware of, well, you should be aware of. And also the data science should ask the medical expert for verifications on the data analysis results. You know, this is key because in the end, this will only work if we can create kind of hybrid teams at the point of care. And by this, what I mean is that we need not just the medical doctors there, yeah, and the data scientists, I don't know, at the university or in a private company. We need them to work together in teams, in multidisciplinary teams, not just the data scientists and the medical experts, but at this point, it will be necessary also to get involved ethics experts and legal experts. Only with these multidisciplinary teams, we can really get this thing working, you know, in a real manner at the point of care. I don't know if I'm running out of time. I can stop here if you want, or I can continue.
You've got a bit more time. It's
excellent. Now, just a couple of examples then. You know, and these are examples from my own research. This is from a paper we published back in 2009, Outlier Exploration and Diagnostic Classification of Multicenter Proton MRS Brain Tumor Data. This is brain tumors, neuro-oncology. Yeah, this was published in Neurocomputing. We just wanted to check whether in a European project database there were outliers, and if there were outliers, what were they about? Yeah, what type of outlierness, typicality were we finding there? Well, we did a few, well, we applied a few methods. We applied visualization, tried to find outliers in different ways with different measures, and we found a lot. And we found things that which were kind of weird, because, I mean, we had been told that this database was fully curated, you know, like all cases in there had been revised, and, you know, doctors had, radiologists in this case, had given the green lights. Everything was hunky-dory. But what we got at the time was what you see in these examples on the right-hand side. You know, the dotted points are real spectra from brain tumors, and the solid line is the average spectrum of the type of tumor to which this case belongs. You know, some cases like these were completely weird, with very negative values for some peaks out of the place. You know, the second example, the same. So when we went back, I mean, we got quite a few of these examples that we thought were outliers. When we got back to the radiologist, They told us, no, they are not outliers at all. I mean, only a part, some intervals in the spectrum, some frequencies in this spectrum, we know they are not right because of some artifacts. But with the rest of the spectrum, a radiologist can make an informed diagnosis. We didn't know this. You know, what we meant by an outlier was by no means what the doctors, the radiologists in this case, meant by outlier. For them, these were not outliers. Obviously, for a machine learning classifier, this is a big outlier. Any of these are big outliers. So we actually had to sit down with them, and case by case in the database, we had to agree on which artifacts could be found in each of the spectra. Painful process. But in the end, you know, I mean, we managed to get a proper, you know, understanding between radiologists and data scientists of what we were talking about when talking about outlierness and atypicality and anomalies. Yeah. So beware of prior expert knowledge and beware of finding a proper shared language about these type of things. Otherwise, interpretability goes bonkers. I mean, there's nothing we could do about it. Another example from a very difficult problem, which was also in neuro-oncology, trying to distinguish between metastasis in the brain and high-grade gliomas, very aggressive tumors. Yeah, this is important because therapy, if at all, is completely different, and the diagnosis is completely different. I mean, if you have a metastasis, you have to try at least to attack all the sources of the tumor. But in the case of a glioblastoma, an aggressive glioblastoma, you really have to probably open the brain, yeah, open the skull and perform surgery. These are, I insist, very aggressive tumors. I mean, your survival chances are extremely limited. So but the point is that from images, or even from the own spectra as a whole, this is a difficult problem. It's very difficult to distinguish between a metastasis and an aggressive glioblastoma. So we try to do feature selection, a kind of very intensive process of feature selection in order to make this interpretable. I mean, why this is a metastasis, why this is a glioblastoma. Yeah? We work hard on this, and we came up with a very parsimonious selection of spectral features, yeah, spectral frequencies, 5 or 6, even less, that got us to an accuracy of discrimination between metastasis and glioblastomas, which was better than anything published. We were over the moon about that. We went with this to the radiologists, and they said, this is absolutely useless. Why? Because many of the frequencies you have selected mean nothing from a metabolic point of view. Most of these peaks have a metabolic interpretation. This is creatine, this is lactate, this is whatever, glutamates, yeah? Most of the features we selected did mean nothing. So they were useless. I mean, they couldn't base a decision on that, regardless whether the machine learning-based system said that was absolutely fabulous. So what we had to do was go back to the drawing board and find the best feature selection that was fully explainable. That means that all the peaks selected meant something. That compromised accuracy a bit. We still got nice results. We got our publication out there in NMR in biomedicine, but it was a lesson learned. You know, you can, I mean, only things that make sense can be part of an interpretable process. And in a process of diagnosis like this, interpretability is paramount. Yeah, with these 2 examples, I think I'm gonna finish. I think the argument is made. Just 2-3 headlines as a conclusion. The social impact of machine learning in areas such as medicine, not only medicine, but in many others, cannot be ignored any further. We need to check ethics. We need to check regulations and law. We need to be very careful about this problem of transparency, interpretability, and explainability. And we need, in most application areas, we need interdisciplinary teams in order to get this absolutely right. Thank you so much.